A sudden, blinding flash, an immense heatwave, then a deafening roar. This was the Tunguska event of 1908, an enigma that continues to baffle scientists. What force could flatten 80 million trees across 2,000 square kilometers, yet leave no impact crater whatsoever? We delve into the theories behind this unparalleled catastrophe. On June 30, 1908, at approximately 7:17 a.m. local time, the remote Siberian sky ignited. Witnesses across hundreds of kilometers described a brilliant blue-white light brighter than the sun streaking across the heavens. For many, it was an omen. Eyewitness accounts, collected years later, painted a vivid picture of terror. Farmers were thrown from their feet, houses shook violently, and a searing heat was felt miles from the epicenter. Some believed the world was ending. The immediate aftermath was devastating. An explosion estimated to be equivalent to 10 to 15 megatons of TNT obliterated a vast swathe of forest. Yet, unlike typical meteor impacts, no conventional crater was ever found. The lack of an immediate scientific expedition due to the remoteness of the region and political turmoil in Russia only deepened the mystery. It would be years before the first formal investigation could even begin. The first major scientific expedition, led by Russian mineralogist Leonid Kulik, finally reached the site in 1927, nearly 2 decades after the event. What he discovered was truly astonishing and profoundly disturbing. Kulik and his team found a colossal area of forest where trees were flattened radially outwards from a central point. It looked like a giant insect had crushed the landscape, yet there was no central impact crater. Instead of a crater, they found a zone of standing but severely burned trees right at the epicenter. Their branches and bark were scorched, stripped clean, pointing directly away from the blast's central axis. This peculiar pattern suggested an airburst, an explosion that occurred in the atmosphere above the ground. But what kind of object could cause such immense destruction without reaching the surface? Kulik spent years tirelessly searching for meteorite fragments, convinced it was an extraterrestrial impact. He even drained swamps, believing a meteor might be submerged. He found nothing definitive. The absence of a crater and the lack of meteorite fragments became the central puzzle of the Tunguska event. This profound mystery opened the door to a multitude of scientific and some less scientific theories. The prevailing scientific consensus points to an asteroid or comet fragment entering Earth's atmosphere. This object, instead of directly hitting the ground, would have exploded in an airburst. If it was a stony asteroid, it would likely have fragmented and vaporized due to the immense pressure and heat generated during its atmospheric entry. This would explain the lack of a crater. However, if it was an icy comet composed mainly of ice and dust, it would have sublimated and vaporized even more completely. This would leave virtually no solid residue behind. The airburst theory accounts for the radial flattening of trees and the scorched, standing trees at the epicenter. The blast wave would have traveled downwards, hitting the ground with immense force. The heat from the superheated plasma ball would have caused instantaneous combustion and scorching, explaining the burnt trees. The sheer energy released would have been catastrophic. But even with this theory, certain anomalies persist. Some researchers claim to have found microscopic magnetic and silicate spheres in the soil consistent with extraterrestrial origin. Yet these findings have been debated. The sheer vastness of the area and the lack of uncontaminated samples make conclusive identification incredibly challenging. The proof remains elusive. Another intriguing, albeit less accepted, theory involves a miniature black hole. Proponents suggest a tiny black hole could have passed through the Earth, causing an explosion at its entry and exit points. This theory struggles with scientific plausibility. Miniature black holes are purely theoretical, and their characteristics would likely differ from what was observed at Tunguska. Still, it captures the imagination. Other more exotic theories include an antimatter explosion. If a small chunk of antimatter collided with matter in the atmosphere, it would release an immense amount of energy in a destructive flash. However, the existence of naturally occurring antimatter in such quantities is highly improbable, and its properties would leave behind distinct radiation signatures not definitively observed. One particularly imaginative theory suggests a natural hydrogen bomb. This posits that an accumulation of highly volatile gases, perhaps from a comet, somehow ignited in the atmosphere. While the destructive power could match, the precise mechanism for such an ignition and the sheer scale of the reaction remain difficult to explain within known atmospheric chemistry. Some also propose a geological explanation, a sudden, massive release of natural gas from the Earth's crust. This methane explosion could have mimicked an an airburst. However, the energy required for such widespread devastation from a geological event is enormous, and there's no clear evidence of the necessary geological structures or gas release mechanisms in the Tunguska region. One of the most persistent, albeit fringe, theories involves an extraterrestrial spacecraft. This theory suggests that an alien vessel either exploded or intentionally detonated above the Earth. This idea gained traction due to the unprecedented nature of the event and the initial lack of a clear scientific explanation. It remains a popular narrative in speculative circles. However, there is no physical evidence, such as wreckage or advanced technology, to support the alien spacecraft hypothesis. It relies purely on speculation and the unexplained aspect of the event. Our reasoned conclusion aligns with the scientific consensus. The Tunguska event was most likely caused by an airburst of a rocky asteroid or an icy comet. The lack of a crater is perfectly consistent with an object detonating kilometers above the surface. The shockwave would propagate downwards, causing the radial flattening. The intense thermal pulse from the atmospheric explosion would account for the scorched, standing trees at the epicenter. The sheer energy released would be equivalent to a very large nuclear weapon. The limited, ambiguous findings of microscopic extraterrestrial materials could be attributed to the remnants of the object's disintegration scattered over a vast area. The Tunguska event serves as a stark reminder of Earth's vulnerability to celestial impacts. Such events, while rare on this scale, are a constant threat from space. Imagine if this event had occurred over a major city. The consequences would have been unimaginable. It was sheer luck that it happened in such a remote, sparsely populated region. The Tunguska event continues to be studied, offering invaluable insights into atmospheric entry physics and planetary defense strategies. Its mystery pushes the boundaries of our understanding. It remains one of the greatest unsolved mysteries of the 20th century, a powerful testament to the forces at play beyond our world and the fragile nature of our existence within it. What do you believe truly caused the Tunguska event? Do you lean towards a cosmic impact, or is there something more terrestrial, more mysterious at play? Let us know your thoughts in the comments below. Backhand index pointing down. If you're captivated by the unexplained and the chilling truths of our world, remember to like this video and subscribe to Mind Unlocked for more deep dives into mysteries that defy explanation.